Okay, welcome back to another episode. Now I feel like I'm being a YouTuber. Okay, so in here we're talking about lesson 5 and lesson 6. So in here we have a lot of the sketching, a lot of the graph understanding, but most importantly is what are the signs and what are actually the numbers actually helping you to indicate what shifted, what changed, and was it actually flipped in any way. So first thing, we got to analyze every single thing in this graph, actually in this equation, so that it can help us to actually graph it. So again, we have talked about this so many times: circle label, and what actually is circling labeling in log form looks like. So like, first thing, I see log. I know that log. What does the log shape look like? Again, let's analyze it bit by bit. And let me draw it smaller. So the log shape is gonna tell you it looks like a flower sleeve, right? So it's going to be looking like this. Actually, let me change the color. It'd be actually better to indicate the lock will look like this. Okay. And then the next thing is I see the 2. That means my base is 2. Well, my base is just 2. It wasn't actually telling you anything, but I actually need to label it. It wasn't actually telling you much, but you still have to label it. And then X is in normal place. I don't really care about the X. I care about the plus 6. The plus 6 happened inside the parentheses. That means I actually need to think about crazy X's because it's talk about left, right. Now I actually need to write down left 6 units. Okay. Now the next one's going to be negative A. Now a negative A happened outside of parentheses. When it's outside, that means it's up, down. When I see the negative, I know that's going to be helping you to go down 8 units. Now, the units wasn't actually required, but you're just like, oh, left 6, down A, whatever you label, but it would be more accurate if you write the word units. Sometimes it might leave. Oh, what are you counting? Are you counting apples? Are you counting oranges? Are you counting like spaceships and whatever? Units, okay? And in here, do I observe any coefficient? I do not observe any negative sign in front of the x. I do not observe any negative sign in front of the log. So all the coefficients are normal. That means I am expecting this shape without flipping at all. So I'm going to label one more thing. Without literally any flipping. Due to what? Due to no negative sign. Due to no negative sign at all. Okay, now this is all the labeling that I helped myself to sketch it. Now, it wasn't actually required by any of the things in the exam, but it would be the best for you to label it for yourself. Every single time you're going to analyze every single bit. Okay, base, exponents, shifting left, right, shifting up, down, flipping like a single lady dance or flipping upside down. And is it a log? Is it exponential? What shape is it? Just like back in the days when we're doing unit 1 all the way to and unit 2, when we have a quadratic equation. Oh, is it happy face? Or is it a sad face? Is it M shape? Is it W shape? What shape is it? Or is it just a linear line? It's just a straight line. So based on this, I know it's going to be a flower leaf shape. It's going to shift left 6 units, and then shift down 8 units. So let's take a look at this. I'm gonna have my normal leaf shape, something like this, and then I go left 6, right? So let me go down here. Oh, let me draw it better. I'm gonna go here with the asymptote of -6. Why is it an asymptote? Because I used to have an asymptote at 0. Now I move to the left 6. Okay, let me draw my regular one in green so that I can indicate my transformation. Now I move this way 6 of them. Okay, I'm not done. I need to move down A. So I move down A. But the thing is, I know that my things still look like a leaf, but how can I actually tell to move down A? Well, actually, one good thing that you need to do is actually find out the y-intercept. Y-intercept. How do you do it? All you gotta do, plug in 0 as x. So you have log 2. And then what's 0 plus 6? Oh, just a 6. And then minus a. Punch this thing in the calculator. I actually get a negative 5.415. That means my new y-intercept is going to be there. Now, a lot of you guys give me a negative a because you just keep thinking that whatever you got from the log is going to get 0, right? But the thing is, this case is different. Every time when you have a log, the indicating y-intercept is going to be different. You have to use the calculator. Use calculator, okay? Use your calculator. That means I shift all of this. That means I'm going to have a negative 5. Let me find out. Oh, 5.45. So it's going to be somewhere here. I know that my asymptote is going to be here. So it's going to be something like this. Okay, it's going to be something like this. Just like that. So let's take a look at question number 2. Again, in here, before I move on, I'm going to tell you again, find y-intercept, find all the base, all the shifting, and then, okay, is there any flipping upside down or left, right, left side, right? And then make sure that you label the new asymptote because asymptote shift with you. And then y-intercept, you need to have a new calculation. So let me write it with other color. Y-intercept, new calculation for y-intercept. All good? Okay. Now question number 2. Now in here, a lot of my friends are actually confused. So let's label it. Again, I see it -2. Okay, negative sign telling you that to flip where? Upside down, right? So let me label it upside down. And then a 2 indicating an enlargement. Okay, and then here is need a good analyze. 4 minus x. Now let me change it back into the normal color. This equal to x minus x plus a 4. So again, I only move this minus x down and then the positive 2 to the back. So now, do you see it super clear that in front of the x there is a minus sign? That means you also flip where? Right side left. So just like a single dance, now your right side is left. And you also have a vertical shift. That means you're moving 4 to the right. 4 right. Again, this is crazy. Oh, sorry. Actually, not right. Sorry. Crazy axis. So it's actually 4 left. Now, one more thing. Remember, I have shifting. That means I need to use a new calculation for y-intercept. New y-intercept. New y-intercept. Again, new one. So I'm going to label right here. I'm going to find my new y-intercept. So after I plug in 0, so I'm going to have a -2 log base 2 with a 4 minus 0, which is a 4. Now, by hand calculation, you know that log 2 to what power is 4? Oh, it's just 2 powers. So -2 times 2, you have a -4. So -4. Y-intercept is a -4. So -4, -4. This is not -4 and not -4. And then I know that regularly, my log will looking like a flower, right? Flower leaf. Now I have to flip left side right side left, right? So that means my new one will looking like this. Now here tell me upside down. So that means that I have to use this, the green one to upside down. So let me change it to the blue one. Upside down. Okay, so it's going to be something like this. Because now here is going here. The bottom now is going to top. So let me erase every crazy things. Now we're looking like that with a y-intercept of -4. So A is the only answer. Okay? So A will become your answer. Again, normally I expect something like this. Okay? It's like a leaf. Now it's going to be going from bottom to right. After you're upside down, after you're left, right, you're going to go this way. After you upside down, you're going to go this way. Okay? Or you can start with this upside down first. It's okay. Upside down. Right side left. So it's going to be something like this. Okay? So everybody, make sure that everything is going to be moved left, right, up, down. All you got to do is analyze how the shape, how the trend is going. Okay? So this is how you're going to have your answer at letter A. The most important thing is your y-intercept. It gives out a lot. It's going to either A or B. It actually ruled out a lot of things for you when you're actually finding y-intercept. Last time when you guys are doing this as an exit ticket, a lot of you guys know the shape look like this. Great, but you forgot to calculate the y-intercept to find out that is it A or D. Again, y-intercept is very, very, very important. Again, y-intercept. Okay, now let's take a look at lesson number 6. Okay, lesson number 6. And here we're actually using all our property to actually expand it or combine it. Okay, it says number 1 says expanded. We use our rule. ln have to be applied in every single chunk in here. That is our normal distribution. And ln, we have the top, we have 5 and x. Let's take a look at this, break it down into parentheses. I got 5 times x, let me change it to a dot, it's easier. 5 times x, and then not times anymore, but a divide. Divide by y. So I will have a ln 5 plus ln x, and then minus an ln y. Again, I use this scribbles as I mentioned in the last episode because like people love to see not a 1n, not a letter L, just like a 1, because like to hardly distinguish from it, it was like we have to use a scribble one. Use a scribble one. Okay, like a curly L. And here we have ln5 plus lnx plus minus lny. What if I change this letter a little bit? So as I mentioned in the class, like whatever's on the top is definitely using the positive sign, just like this. And then whatever's the bottom deserve a negative sign. So what if I change it to ln? I'm going to erase this whole thing so I can actually have more space. What if it's ln 2, and then z, and then y, and then x? Just like normal, whatever's on the top is going to deserve a positive, whatever's at the bottom deserve a negative. So it's going to be ln2 plus lnz minus lny, and then minus lnx. Whoever's at the top, positive. Okay, whoever's the bottom, negative. Just like this. Okay. Let me erase this. So far, so good. I think it's going to be okay. So whatever's on the top, positive. Whatever the bottom, negative. Okay? So whatever rule that we have used, there's only like 3. By the time that when we're talking about lesson 6, there's only 3 of them. Actually, we talk about the product rule, and then quotient rule, and then one more is just our power rule. So whoever's using times, whoever stay on top, there's a product rule. Whoever makes you stay at the bottom or using a fraction line or anything involved with the letter division or the sign division, the sign division is actually the quotient rule. Okay, let's take a look at the bottom one. Let's take a look at this step by step. In here, I am actually having this as condensed. That means I need to combine it and then use your calculator to find the answer. Okay, now in here, I know that with a coefficient 3, I cannot actually help myself to combine these two. So first step, when I see a coefficient, I have to make it as a power. Now that is our power rule. Make a coefficient into a power. So this chunk actually will become log base 4 with 2 to the third power. Again, just like move the 3 to the power, move the 3 to the power, okay? That's going to be a coefficient become a new power. That is called your power rule. Okay, now I have a log 4 9 and log 4 2 to the third power. Now I can combine them. Okay, if you are a person who are easily distinguished, was 2 to the third power just an 8, right? So you can actually make this into log base 4 9 minus, is it minus? Yes. Oh, sorry, actually it's a plus. And then the log base 4 8. Based on that, log base 4 and log base 4 are giving you that, okay, this is going to be good to combine. I'm going to have a log base 4 with a parentheses because it's a plus sign with a product rule telling you that it's going to be 9 plus a. Sorry, this 8 is ugly. Just like this. As an answer, you're going to have a log base 4 72. When you punch in a calculator, nothing crazy. All you got to do again is just punch in a calculator, right? So let me look at the answer. When you punch it in calculator, you are having a approximately 3.085. Now, actually, after that, you have a 9624. This is a 4. But the thing is, if you need to round it to the third decimal, this 9 is actually, which is your 4th place, is actually changing the life of a 4. So this is why you erase the whole thing. This become a 5. Okay, again, rounding is very important. Step-by-step rounding, okay? Let's take a look at number 7. Lesson 7. Yes, lesson 7. Well, actually, I can finish 7 and 8 at the same time right here. So, in here, we're going to solve each equation. Again, we have talked about lesson 7, which is called our equality rule. Equality. Or so-called identity. Identity. Oh, right there. I hate spelling. Okay, so look at the log, observe the log and the log. These two are the same. That means that doesn't matter Miss He standing right here. our Mickey Mouse ear is going to be the only one that I need to compare and set it equal to each other. So that means I drag this part out, drag this part out. Oh, sorry. Actually, drag this part out, set them equal to each other because I see an equal sign. Again, whatever that is the same as the log or whatever the base is going to be for the exponent, all I need to do is just like ignore this whole thing because I'm going to pretend that they don't exist because Miss He wearing a Mickey Mouse ear or Miss He wearing a Minnie Mouse ear. As long as I'm saying equal, Miss He and Miss Here, you don't need to care about the person who's at the standing in the front. All you got to care about is the Mickey Mouse ear. So I'm going to set 10 minus 4x equal to 10 minus 3x. As we know that we like to combine like terms, so move the 4x to the other side, I got 1x. Move the 10 to the other side, I got 0. So 1x equals 0? Just 0. Everything has an answer. Okay, next one. How to actually combine this? It's okay to use log. You can actually solve it with a log. 3, 9 equal to 2n minus 2. And you know that this chunk on the left side is going to give you a 2. So 2n minus 2 equals 2, so n equal to 2. But I don't like to use log. I don't want to punch in the calculator. I don't want to do any of the calculation with the calculator. So how would I do it? I am going to translate my 9 into something with the same base so that I can actually compare the Mickey Mouse ear only. So 3, 2n minus 2 equal to, what's 9? Oh, 9 is just 3 to the second power. So 3 to the second power. Again, Miss He don't care about my base since the base are the same. Just like Miss He don't care about Miss He myself. I only care about my Mickey Mouse ear. I only care about my ears. So 2n minus 2 equal to 2. Same thing. When you solve it, n equal to 2. So again, it's going to be very convenient for you to actually translate this into the number that is actually having the same base. Again, having the same base. So in this case, you don't need to care about whoever's wearing Mickey Mouse ear. You only need to care about the Mickey Mouse ear itself. Okay? Okay, let's take a look at the 7, number 2. Lesson 7, number 2. And here, this is actually a combined of how to find out all of the answer from previous lessons. We have talked about logarithmic, we have talked about exponent. Now is a good chance for us to combine everything that we know in the unit 3 to find an answer. Now in here, it says exceed 8,000. That means I want it to be greater. Again, we have talked about this in class, like literally the same thing. Okay, exceed 8,000. Again, the population, that means the PT is going to be replaced. Again, P just for population and T is at a certain time. That means the population at a certain time. So this is just a number. We don't actually need to replace the T. We just need to replace the P because the parentheses are just like, oh, telling me that at a certain time. Okay, so, and I want to talk about exceed 8,000. That means 1600 and then times the E, 0.21t exceed 8,000. Again, I want it to be greater because the exceed means greater. Okay, first thing, when I see times something, I want to get rid of it so I can actually use division. So E, 0.21t greater than 8,000 divided by 1600. That means this whole thing will be translated into a number 5 if you punch it in the calculator. Now, the next step is going to be using a log. You can put an ln on both sides, or if you're a person who prefer to use it, log E5, and then it's going to be less than 0.21t. Or you're the person who's using log ln on both sides, that's going to be perfectly fine too. Okay, so that means in here, ln and the e is going to be canceled. This is going to be a recap for how to use the exponent of the e. So that means that if you have a log 770.21t, all you got to do, log 77 is going to be canceled out. All you got to hear about is just 0.21t. And then if you just have a log 200 and 200 to that power, this whole thing's going to cancel out too. So in here, this ln e is going to be canceled out. All you got to left with just 0.21t greater than the ln5. And then how do you actually get rid of this number? Oh, by dividing, because 0.21 times t, right? Times t. Okay, then I'll have t greater than ln5. By the way, don't forget, this is a divide by 0.21. Some of you, when you punch in the calculator, forgot to close the parentheses, so this is why you have a wrong number. So when you close the parentheses, actually this number will become 7.66399. And if you do the rounding, you have approximately 7.66 years. Okay, this is how it goes. Okay. Now let me show you the other way too, if you're actually a person who would like to use the log form. So I have log, just like usual, base, answer is 5, and then equal to 0.21, which is your power, 0.21t. After you solve it, you got the same thing, because it's log E5 just ln5, okay? So ln5, 0.21t, and then you have to divide by 0.21 on both sides, okay? And then this is how you get the 0.66 again. By the way, if it's exceeding some time, you have to be, have to be greater, because exceeding some time, greater than, okay? So this is up till lesson 7.